Hello everyone, my name is Leonard Gomes. This is our final project of Microprocessor CC341. We inspired to accomplish this project and make the work done under the supervision of our honorable faculty, Dr. Jia Uddin. This is the whole project diagram. We used half-bridge load sensor, HX711 24-bit load sensor amplifier, Bluetooth module, LED display, breadboard servo motor and microcontroller. We use Arduino Uno board. For power supply, we use DC power supply from the lab. Now you can see the whole process of our project, how the gate will open and close with the help of microcontroller. You can see the gate is opening and closing. To begin with, we need to pair the Android phone with Bluetooth module. Since it is the first time, so it will take few seconds for initialization. We can see the initialization is taking place. Then the display will show welcome to the driver, and when the load is sensed in the load sensor, if it is in our range, then the car will be detected and it will ask for password. Then we have to provide our desired password with the help of Android phone. If the password is matches with our system, then the gate, it will show the gate open, and then the gate will open with the help of servo motor. When the driver enter in the parking lot, then you have to close the door by giving the closing password. This is our closing password. Then the gate will automatically close with the help of servo motor. In this way our project will work. Thank you.
Hello everyone. So we have seen so far how this automated car parking system is going to work. So now we are going to describe all the equipments here working together. So first of all, we are going to connect the Bluetooth module, which is this one. So the name of the Bluetooth module is HC05. It is going to connect it with the app that we have downloaded from the third party Google Play Store. So when it's going to connect it with the Bluetooth module, the weight sensor we have used, so the name of the weight sensor is HCSENS0009 load sensor for our project, and this is the load sensor. So first of all, the load sensor, what is the load sensor? The load sensor is a cell which is a physical element that translates pressure or force into electrical signals. So our specific load sensor has been followed the strain gauge load cell mechanism. So what is the strain gauge load mechanism? So this is the strain gauge load mechanical cell mechanism, which is a Whinstone bridge configuration. So it is a 3-wire Whinstone bridge configuration that is working on in our project. So the electrical signal output is typically in the order of a few millivolts and requires amplification by instrumental amplifier before it can be used. So what is the amplifier? So this is our amplifier. So the load cell amplifier is a small breakout board for the HX11 IC that we have used in our project. So this is the HX711 IC that allows us to easily read load cells to measure the perfect weight. So by so this is a 2-wire connection system the load amplifier has. First of all, it is connected to the Arduino with 1 wire. This is our Arduino. So it is connected with the Arduino with the 1 wire. And it can be connected with any of the GPIO pins of the microcontroller, which is the Arduino we have used. And secondly, by connecting the amplifier to our microcontroller, we are going to able to read the changes in the resistance of the load cell, which is going to be read in here. And with some calibration, we are going to able to get very accurate weight measurements through the combination of the load cell and the load cell amplifier that we are using in this project. This can be handy for creating our own industrial scale, but the process of control and simple presence detection can be used by this HX711 IC amplifier, load cell amplifier, and the HCSENS009 load sensor, which is that we have used in our project. So this this load cell use a 3-wire Winston bridge configuration to connect the HX711. So we can see here there is 3-wire which is red, black, and green. This 3-wire is going to make a Winston bridge. Over here we can see this black, red, and white wire is made a Winston bridge to connect the amplifier. See this wires, which is kind of blue, or I don't know what is it, and the blue and the yellow one and the orange one. This four, basically these are 2-wire has been outgraded into 4-wire. So this 4-wire made a Winston bridge with the 3-wire of the load sensor, which is black, red, and white. So again, when the car is going to enter on the load sensor, the load sensor will give a electrical signal to the load sensor will be giving a electrical signal to the amplifier, and amplifier is going to measure the correct weight for our, and when the weight is in our range, for your better information, we have set the range to 10 to 1000 grams in our application Arduino code. So when the range is between 10 to 100 gram, you can say the LCD display we have been using here. So we are going to describe it later. So the LCD display will say that car has been detected, and the app will is going to say that the car has been detected. Then the car is already connected with the Bluetooth module. So let's look what is the Bluetooth module we have used. So the name of the Bluetooth module we have said before that it is the HC05 Bluetooth module. So this you can see this blue part. This blue part is the BT board, and the green part is the sub module which is soldered on the top of the blue part, and this green part is the sub module of the HC05 which is soldered in the top of the blue board. The HC05 module includes the radio memory chips. It's very small here, you cannot see properly, but I am trying to give you a better look. This one is the radio chip, radio and memory radio chip, and this one is 8 MB memory chip, and this short one is the 26 megahertz crystal antenna and RF matching network. The right section of the BT board has connection pins for power and signals, as well as 5 volt to 3.3 volt regular LED and level shifting. So this is the Bluetooth module we have used. So when the car is detected by the load sensor, the LCD display will be saying that yes, the car has been detected, and the Bluetooth app the app we are using, that we are showing you in the we have shown you in the further portion. The app is asking for a password to open the gate or to close the gate. You can see the gate, and there is a servo motor.
Hello everyone, I am Shounak Banik. Now I am going to describe that what is servo motor and LCD display and how it used in our project. So first of all, here it is a servo motor. After giving the command from the mobile to the Bluetooth module, then the servo motor will work, and it will use in our project when the car will enter in the garage, and when the car will exit from the garage. So what is a servo motor? Servo motor is a rotary actuator that precise control of angular or linear position, velocity and acceleration. Here we rotate the servo motor from 0 to 90 degree, and the motor is connected with the power supply and with the Arduino Uno board. Then come to the point of LCD display. We use LCD display to show different command from the whole program, like get open, get close, welcome, card detected, etc. LCD is a flat panel display or other electronically modulated optical device. In our project, this LCD display is connected with the breadboard and the Arduino Uno board. So whenever we give a command like give the password, and if the password matches, then the display will show that get open. After that, if we press the button of get close by the mobile phone, then the servo motor will work, and in the display it will show that get closed. So like this type of action, the LCD display will show different type of command to so LCD display will show different types of commands to the driver, so that the driver will know that what is going on. That means if he will enter into the garage or not, or what he will do. So this is all about our project. If you have any question about this project, you can ask. Thank you.